Okay, so in the previous video we talked about solving trig equations using the calculator. In this video we're talking about solving trig equations by hand. Now, I'm going to go tell you solving trig equations by hand is difficult, even for me sometimes. So if it just is too much for you, then go back to graphing, no shame in that. But if you're especially in the honors class or even in the regular class and you want to try to do it by hand, that's fine, because when you go to that higher level math, they're going to expect you to do this by hand, okay? So the graphing is kind of just a get out of jail free card, but you really need to try to push yourself and do it by hand if you can. All right, so when you're solving by hand, we're always going to start by drawing a circle of radius 1, okay, because that's what the calculator is thinking about. So when we use the calculator is thinking about a circle of radius 1, so when we're doing it by hand, we want to draw that same circle. We want to get the trigonometric expression, sine, cosine, etc., whatever we're working with. We want to get that part by itself first. Then we're going to graph the line y equals for sine of theta and or x equals for cosine of theta. Essentially, if you have sine, we're going to graph a horizontal line. If you have cosine, we're going to graph a vertical line, and we're going to graph that on the same graph where we put our circle of radius 1. Then we're going to use the inverse trig ratios to find the initial values of theta, and then use the graph in symmetry to find the remaining values of theta. And then we also had this identity. Identity is kind of a rule that's always true. We don't have to prove it. It's already been proven. But it's called the Pythagorean identity. So it's very similar to the Pythagorean theorem. A squared plus b squared equals c squared. Pythagorean identity is cosine squared of theta plus sine squared of theta is equal to 1. So we might use that identity to help us out in just a few minutes. So in example 22, I'm solving 5 sine of theta minus 3 equals 7 for theta between 0 degrees and 360 degrees. We already solved this by graphing in the previous video, and we saw that there was no solution, so hopefully it's going to work out that same way when we do it by hand. All right, so first off, I wanted my thing says to start off by drawing a graph with a circle of radius 1. So that's what I'm going to start with every time when I'm doing this by hand. So if this is a radius 1, that means this point right here is 1, 0. This point on the other side is negative 1, 0. This point on top on the y-axis is 0, 1. This point down here on the y-axis is 0, negative 1. Okay, so this represents the circle that the calculator is programmed to think about automatically. Now what I need to do is get sine of theta by itself first. That's my first objective. So I'm going to start by saying plus 3 on both sides. Cancel out, so 5 sine of theta is equal to 10. And now I want to get sine of theta by itself, so I want to divide by 2. Or sorry, divide by 5 on both sides. And 10 divided by 5 is 2. So sine of theta equals 2. Well, remember we said graph the line. Since it's sine, we're going to replace sine with y equals. So y equals 2, which is a horizontal line. And here's radius 1. If I extend my line up just a little bit, my axis up. So the line y equals 2 is going to be somewhere up here. There's no points of intersection of this blue line with our circle that we're trained to think about. So, since there's no points of intersection, then there's no solution. And that's exactly what we found in the previous video when we did the same problem on the calculator. No solution, no points of intersection. All right, so let's move on and do one more problem. Example 23, we've already done this problem. We saw that there were 4 points of intersection, okay? So we're solving 10 sine squared of theta minus 3 sine of theta equals 4, and theta is between 0 and 360 degrees. So I'm going to start by drawing my circle of radius 1, just like we did in the previous problem. Again, every time you're solving these trig equations by hand, this is always your first step. So this point is 1, 0, negative 1, 0, 0, 1, and then 0, negative 1. I like to put the points on here, that way I just emphasize that this is a circle of radius 1. Alright, now what I want to do is to get sine by itself. But I have sine squared and regular sine, so I need to use a trick. What I want to do, instead of sine squared of theta, I'm going to set a variable, so I'm going to call it z. So z is going to be equal to sine of theta, just regular sine of theta. And this is kind of the same trick that we did when we talked about factoring, okay? If we saw something crazy looking, we can try to rewrite it using a different variable to make it look a little bit nicer. So everywhere I see a sine of theta, I want to put in a z. So the problem now becomes 10z squared, because I had sine squared, minus 3z equals 4. Well, that already looks a whole lot better. So now what I'm going to do, since it's a quadratic, which we've solved before in previous chapters, I'm going to get everything on the same side. So minus 4. Combine my terms. So I have 10z squared minus 3z minus 4 equals 0. And now I'm ready to factor, okay? So I have 3 pieces. It's a quadratic, so this is the bottoms-up method. If you don't remember that, go back and watch that video. The bottoms-up method pretty much says we're going to take the first piece and the last piece and multiply those. So we get z squared minus 3z minus 40. This is still equal to 0. Remember, the middle piece stays the same. Now what we're looking for are factors of negative 40. That'll add up to negative 3. And I think that's going to be negative 8 and positive 5. So z minus 8 and z plus 5. And that's still equal to 0. Now we want to double check that we have the right 2 factors. We're going to first multiply negative 8 and positive 5, and we get negative 40, so that works. Then we're going to add negative 8 and positive 5, which is negative 3, so that works. So these are our 2 factors. So now what I want to do is use the zero product property. Again, we talked about that in previous chapters, and set each factor equal to 0. So z minus 8 equals 0, and z plus 5 equals 0. All right, so I want to get z by itself, so plus 8, both sides. So z equals 8, minus 5, both sides. So z equals negative 5. All right, but z was equal to sine of theta. Z was equal to sine of theta. All right, so what I have is sine theta equals 8. Actually, I missed a step. Good thing I caught it. Sometimes this happens. Just go back, erase, start over. So, again, bottoms up method, I forgot the whole bottoms up part. Okay, so let's go back and fix it. I first multiplied by 10 each of these, so now I need to divide by 10 to take that 10 out of the problem. Sorry about that. So divide by 10. All right, clean up each fraction. Sometimes you just have a light bulb and it tells you that you're an idiot. You need to go back and fix things. So that's what happened to me. All right, so negative 8 divided by 10. I get a decimal and turn it into a fraction. I get negative 4/5. So this factor becomes z minus 4/5. All right, and then 5/10 is the same thing as 1/2. So z plus 1/2. And it's still equal to 0. All right, so now we want to use the z, bring the bottom up. So we have 5z minus 4, and then 2z plus 1. And that's all equal to 0. Okay, so now what we want to do is use the zero product property. So 5z minus 4 equals 0, 2z plus 1 equals 0. We want to get z by itself for each one of these 2 separate equations. So I'm going to start off with the equation on the left, plus 4 on each side. So 5z is equal to 4. Then you get z by itself, so I'm going to divide by 5 on both sides. So z equals 4/5. Now I'll go to the right equation. Start off by subtracting 1 on both sides. So 2z equals negative 1, and then divide by 2. So z is equal to negative 1/2. All right, well, instead of z, we're going to go ahead and put back in our sine, because that's the very first thing we did. So everywhere I see a z, I'm going to say sine of theta is equal to 4/5. Sine of theta is equal to negative 1/2. Now, these are lines that we're going to graph. So instead of sine, we're going to think about y equals 4/5. Y equals negative 1/2. And we're going to graph these lines on our circle. So 4/5 is 0.8. Use your calculator if you don't believe me. But remember, my circle was radius 1. So 0.8 is going to be about here. So y equals 4/5. And then my other line that I'm going to graph is y equals negative 1/2. Again, circle is radius 1, so it's going to be about halfway. So y equals negative 1/2. That means I have 4 points of intersection now on the circle, which is good because when I solved this by graphing, I found 4 points, or 4 points of intersection on the graph. So now I need to figure out what those actual points are. So to do that, I'm going to go back down here to my equation. I'm going to use the inverse trig relations on my calculator. I'll start with sine, so I'm going to go inverse sine to figure out what one of these angles are. So I'm going to say theta equals sine inverse of 4/5. And I'm going to do this in degree mode because that's what it told us to do in our window range, which is between 0 and 360 degrees. Make sure your calculator is in degree mode. So I'm sine inverse. To do that, you just, again, yellow button sine of 4/5. And I get 53 degrees, approximately 53. I'm going to go to the nearest whole number. Again, the more decimals you include, the better. All right. And then I'm also going to do the same idea over here for this trig equation. So theta equals sine inverse of 1/2. I'm going to use my calculator. So second sine of negative 1/2. Second sine of negative 1/2. Might help if I could actually type. And you get negative 30 degrees. I forgot my negative sign here. I'm going to put that back in since I just noticed it. That's negative 30 degrees. Okay. But I want to think about, I'm going between 0 and 360 degrees. That means my degree is going to be positive. So to figure out what the positive angle is, or the coterminal angle, I'm going to say plus 360, which means my positive angle that relates to negative 30 degrees is 330 degrees. Great, so I have 2 out of 4 of my points of intersection. So I'm going to put those on my graph. Let's start off with 53 degrees. 53 degrees is here. All right, and notice that there's some symmetry going on. So 53 degrees and negative 53 degrees if I go over here. All right, and I have 330 degrees would be over here in this quadrant. Again, we have some kind of symmetry going on. All right, well, what I want to do now is to figure out what my other 2 angles are. Let's think about 330 degrees first, because that might be a little bit easier. We knew that the angle to get here was negative 30. Well, what I'm going to do is flip my taco over. We'll think of this circle as a taco shell, and flip it over, and so positive 30. But then if I extend this line, it's going to hit this other point that I need. So to get from here to here, I've gone half of the circle, which is going to be 180 degrees. So what I want to say is 30 plus 180. 30 plus 180, which is 210 degrees. So this point right here is 210 degrees. Great, I've got 3 out of 4 of my answers. Now I want to do the same idea with 53 degrees. Here's 53 degrees. If I fold it over, it would be about right here, and that would be negative 53 degrees. Negative 53 degrees. But if I extend that line, then I'm going to hit this point. So I'm going 180 degrees because I'm making a straight line. So what I'm going to say is negative 53 plus 180. Use my calculator here. Negative 53 plus 180, and it's 127 degrees. So 127 degrees lives here on our circle. And these are the three, again, we rounded a little bit, so this might be a little off. Again, 53 point something, 127 point something. 210 on the calculator was exactly 210. 330 on the calculator was exactly 330. But what we've done is solve this equation by hand. It took a lot more work than using the calculator, and our drawing is very complicated. But before the invention of the calculator, this was the only method. And again, especially if you're planning on going on the honors pre-calculus or even beyond that, AP calculus, you're going to be doing this a lot, and you're going to be doing it by hand. Very rarely will they let you use the calculator. They might let you use it to check your work, but you need to do it by hand. As far as my class goes, if you want to stick with calculator, it's fine. But I would definitely encourage you, especially if you plan on going to that next step, try to do it by hand. And then if you get stuck, ask questions or use the calculator at least to figure out what your answer should be and try to work it out yourself. But get help from somebody or me. That's it for this video and this chapter. Let me know if you got questions.